Have you ever really stopped to think about what a memory is?
Is it like a perfect video recording of the past or something else entirely?
Well, we're about to dive in.
Because that's the huge question at the heart of a really fascinating debate happening right now in philosophy and neuroscience. I mean, what if calling up a memory uses the exact same mental machinery as, say, picturing a dragon or just planning your next vacation?
Now, this isn't just some casual thought experiment. It's a deep-seated conflict between two totally different ways of understanding how our minds work, and it all boils down to two main theories.
Okay, so on one side, you've got continuism. This theory suggests that memory and imagination are basically the same tool, just used for different things. Think of it like your brain has one super powerful graphics card. You can use it to render a memory of the past, or you can use it to render something totally new. Same hardware, just a different setting.
And on the other side, we have discontinuism. This view says, whoa, not so fast. It argues that they are not on some kind of spectrum. They are fundamentally different kinds of mental processes. There's a hard line drawn in the sand. Memory is its own thing, and imagination is something else entirely.
So here's the bottom line. Continuism sees them as two sides of the same coin, just a difference in degree. But discontinuism? Nah, it's apples and oranges. I mean, sure, they're both mental states, but they're ultimately different in their very nature. And that one distinction changes everything about how we understand the mind.
Now, for a good long while, the scientific momentum has been with team sameness. So let's take a look at why this idea, that memory and imagination are basically a package deal, got so popular in the first place.
The reigning champ for this view is called continuist simulationism, and the idea is pretty slick, right? Your brain doesn't have a memory button and then a separate imagination button. Nope, it just has one powerful simulation engine, and you can use it to construct a scene from your past or a scene from a possible future.
This is all built on a scientific hypothesis called systemic sameness. It proposes that there's this one single unified network in the brain, an episodic construction system, that's doing all the heavy lifting for both remembering personal events and imagining them. And look, the evidence for this single system seems really strong at first glance. Think about it. Developmentally, kids get good at remembering their birthday parties right around the same time they get good at playing pretend. Neuropsychologically, you have these famous cases of amnesia where, when the ability to remember the past is damaged, the ability to imagine the future often goes right along with it. And of course, the big one. Brain scans show the same network of brain regions, the default mode network, lighting up for both tasks. It's a very tidy story, but maybe a little too tidy. Because when you start to look a bit closer at the evidence, some pretty serious cracks begin to appear in this whole single system theory. So let's start asking the tough questions. Is the evidence really as solid as it looks? What if we've been oversimplifying the relationship between these two incredible mental powers?
Okay, let's go back and re-examine that default mode network evidence, the overlapping brain activity. Turns out the overlap isn't the whole picture. What's really interesting is that while there is overlap, there are also key differences. Critics point out that imagining the future consistently requires more brain activation in certain areas than remembering the past. It's just more cognitively demanding, which kind of suggests it's not the same process running on different content. And that powerful link between amnesia and a lost imagination, that also starts to fray when you look a little closer. The correlation just isn't a perfect one-to-one match.
For example, studies have found amnesiacs who are impaired at remembering the recent past but are still perfectly capable of imagining plausible future scenarios. And get this, there's even the case of a patient whose memory got better with treatment, but their ability to imagine the future didn't improve at all. Now, if it's all one system, how is that even possible?
There's another problem, too. The theory has kind of become a victim of its own success. Proponents have expanded it to explain not just memory and imagination, but also how we perceive events in the moment, and even how we process general knowledge. And when one system is supposed to explain almost everything, its specific explanatory power gets, well, a little watered down.
This also reveals the theory's biggest blind spot. It really struggles to explain things that are unique to memory. Processes like memory consolidation, the way our brains stabilize and store information for the long term, don't seem to play a role in imagination. A single system should be able to account for that, but it really can't.
So if the old theory is flawed, what's the alternative? This is where a new, cutting-edge idea enters the picture, and it aims to solve the whole puzzle.
Take a look at this table from the research paper. It maps out the philosophical landscape. And for years, there's been this empty box.
a theory where memory and imagination are different in kind, but that doesn't rely on old, outdated ideas about memory traces. A new theory proposes to fill that very gap.
It's called discontinuist simulationism, and it's a brilliant synthesis. It agrees that remembering is a constructive simulation. It's not a simple replay. But, and this is the key, it argues this simulation is run by a specialized memory system that is fundamentally different from the system we use for imagination.
So let's break down how this new theory works. First, it posits two different systems. This makes memory and imagination different in kind, satisfying the discontinuists. But it still holds that memory is a simulation, a creative reconstruction. And crucially, the reason we trust our memory is because its specialized system is highly reliable and is designed to prioritize information you actually experienced firsthand. This new perspective elegantly solves the problems we saw earlier. It can explain memory-specific processes like consolidation because it gives memory its own dedicated hardware. It accounts for both the similarities and the differences we see in brain scans and in those patient studies.
So, the ultimate takeaway here is a powerful shift in how we think about this. Memory isn't just the imagination machine switched to past mode. It is a completely different piece of equipment built for a specific and vital purpose to reliably simulate our personal past. And that leaves us with a final thought to chew on. What does it mean for our sense of self if our memory isn't a dusty library of facts we retrieve, but an active, dynamic simulator constantly reconstructing our past for us?